Hello everyone. We are Hello everyone. Welcome to our podcast. Today our group is going to discuss about an innovative technological intervention developed in Kerala. We'll explore what the technology is, why it was created, and the impact it has made.
We also have a professional who worked on this project and they have completed the development stage. We will ask them a few questions and understand their experience and insights.
Thank you for joining us today, ma'am. To begin with, can you briefly explain the projects that you have worked on?
Okay. So before I start, I'll introduce myself. I'm Stella Matthews. I was born and brought up in Kottayam, Kerala. And I did till my master's in Kottayam. And then I went for PhD in South Korea. I did my PhD in chemical engineering, material sciences and engineering from Busan National University. And after that, we moved to Canada as a postdoctoral fellow. And I worked as a researcher researcher in University of Alberta till 2018. So that's my what do you say, curriculum vitae or something like that. That's my research background. And to start with, I have worked with several projects during my research span, and most of them are based on material development for engineering technologies. So basically what I do is I develop innovative materials and we find its application in different forms of technology. So talking about my PhD thesis work, I developed flexible substrates for organic light emitting devices. So for example, when I started my first day in my as a researcher, as a PhD student, my supervisor took a pen out of his pocket and he had something that he was able to roll it out. And he told that this is the future of computer. So you will have a pen that you can put in your pocket, and when you roll out, the screen comes out. And my task or my project was to develop a flexible screen out of it. So the screen should be durable and it should be conducting, it should have diodes, it should be like a substrate that can, where you can deposit the diodes and the electrodes and everything on top of it. So this project was actually linked with the, it's in 2004, okay? So that was a vision. And now you know that Samsung had brought up with the flip phones. So they do have a substrate that is flexible and all the stuff, right? So you can see it started in 2004. That was a big project that was ongoing in Korea. A lot of scientists worked on it, and that's the outcome that you see. And I'm the itsy bitsy tiny startup fresher who got an opportunity to see that, I would say. So that was where I started. And then when we moved to Canada, in UFA, UFA means University of Alberta. I used to work with same material development and development of materials which can be applicable in different scenarios. And when I retired, okay, by the way, I retired in 2018. So when I retired, I was working on a project called 4D printing. So we know that we do have 2D printers and then the 3D printers where you can print small, tiny things like toys and everything. And then there is one more dimension that is added to it. That's 4D. So my 4D, the fourth dimension was functionality. So that's what I developed. If you want, I can share a news report that came in Canada so that you will understand more rather than me talking about that, more what I did and what is the coverage I got. Are you guys interested?
Definitely, ma'am.
Definitely, miss.
Am I sticking to the topic or your requirement, or am I going overboard with everything?
Not at all, miss. Not at all. Not at all. You're on the right path.
Okay. So far, I don't see any yarns, so I think I'm fine. So I'm going to share my screen, okay?
Yes, ma'am.
Are we on live right now?
Yes, ma'am.
Okay, so I shouldn't take much time.
Please do take your time. It's a podcast. Not to worry about anything.
Okay, sounds good. Oh, I cannot find. So can you walk me through how to share my screen? So I press this share screen and then.
Ma'am, as you press share screen, I think you can see which tab you want to share, like which picture, which folder you want to share, or something. You can just tap on it if you see share screen.
Yeah,
Or you can, or
it
you
shows.
can share your entire screen. Also, you can share your entire screen.
Oh, okay, share entire screen. That means now what I'm seeing is you guys on it.
Yes.
And then when I play my stuff, it will come, eh?
Yes, yes, yes.
So now can you see the screen?
Yes, ma'am. I can see your screen, ma'am.
And what do you see right now?
Now I'm seeing the news.
Okay, yeah. So this is what I was telling, and then let me play it, okay?
Yes, ma'am.
Oh. Is it playing now? No. It was not playing, eh?
No, ma'am.
Okay, let's do one more trial, eh?
Well, imagine a world where people
Share entire screen, and then share.
It's visible, ma'am.
It's visible, right?
Yes.
And then now how can
Well, imagine a world where people who need an organ donation could simply have one printed for them.
That's one step closer to reality, and thanks to a groundbreaking discovery from the U of A. Celine Go joins us now with more. Celine, this really does sound amazing.
Yeah, so this team is pretty excited about this breakthrough. You've heard of 3D printing. Well, some U of A engineers are the first to do a new type of 4D printing, and that fourth dimension could actually make all the difference for people waiting for organ donors. Material is shaped like a living thing, a leaf. More importantly, it behaves like a living thing, reacting with its environment. You will see bubbles coming out of the leaf, indicating that it is splitting the water and generating hydrogen. Those tiny bubbles have big meaning. University of Alberta engineers have successfully printed a biological molecule that actually functions. It's an important step toward one day printing human tissue or even organs for transplant. And then you can print it just like that, and you will get a structure that when you put it with cells or when you implant it, our body will feel that it's just the natural thing that it already has. That could mean no need for donors and no rejection. It's called 4D printing, with the fourth dimension being function. And this Edmonton team is the first in the world to accomplish it. Here we're printing a knee meniscus. The meniscus is cartilage in the knee. If it's torn, patients often need a transplant. The U of A is on the verge of printing one with human cells that can withstand the pressure of human bones. And you can see how flexible it is. Their patented hydrogel material can bend and may eventually be an effective and inexpensive alternative to donor tissue.
I can custom make my organs, and I can do it in a cheaper version. If you fail also, you can make it more.
Labs around the world are racing to print functional human organs like hearts and lungs. Right now, this team may be in the lead, and it's hoping to stay there.
I'm very excited and glad I will keep working hard on this to make it happen.
That team is now working with the Department of Surgery to test the knee cartilage in animals.
Wow, ma'am. Wow.
Yes, that's back in 2017. So it's like 10-year younger me. And after this, you know what? When you do something in your lab, you do that, and then it's carried over to then it goes to clinical trials. We pass the research and our findings to the Department of Medicine, and they do the animal trials, and then only it comes to actual applications. So all this process is still in research and development, and hopefully when you guys are young adults or something like that. You guys are young adults right now, but when you are like mature people, you will actually see the technology. Maybe I won't be there, but still you guys are the people who are going to get the fruit of it.
Definitely, ma'am. Definitely.
Yeah. Okay, do you have any questions?
So what does this innovation mainly aim to solve?
Okay, so there is a part of research called bionics, or we are putting bioengineering together. So for example, if you want, let's talk about knee meniscus. When you become older, your knee meniscus, the tear and wear of your knees can cause a tear or something for the meniscus so knee meniscus, when you have two bones in your leg, right? And then the meniscus is the one that it's in between. That's the, what do we say, a cushion in between those bones. And when it helps to prevent the rubbing between the bones, to say it simply. So what if when you become older, you know that our all part of our body gets aching. So the meniscus can tear, and then if a tear happens, it's really hard to reverse the process. So there are a lot of people who are waiting for a meniscus transplant. So either you can there are fillers and everything you can inject to make it the cushion back. So instead of waiting for the meniscus to be replanted, and then if you are putting a foreign object in your body, that means the body should not, the immune system of the body shouldn't be triggered when you put something on there. For example, if you're doing a kidney transplant or a heart transplant, you know that the patients wait years and years to get a proper match with their systems, right? So since it's a meniscus, it's not that bad, but still, if your body rejects, then that means you are going to have another set of problems. So instead of that, we were trying to print a meniscus. So the 3D printing, in the 3D printing, have you seen the 3D printing devices?
Yes, ma'am. Yes, ma'am.
Yeah. So you know that in a program, you draw the shape of it, you put the dimensions in it, and you do like the specific nano, micro measurements and everything. And that's how you print, right? So what we do, it was a collaboration between the medicine. So they know the structure and the scan pictures of meniscus. So we make the girl who you saw doing the 3D printing, she was an electrical engineering with me. So it was a team, and I was a team lead. And that she is the one who made the model of it. And then we printed it. And in the printing, the materials that used were called hydrogels. So if you guys are familiar with them, hydrogels?
Not that much. Not
so
that
hydrogels
much.
are polymers, and the main good thing with hydrogels is they absorb around 90% of water. So they can swell to 90% of their volume. That means they can be compatible with because our body is also 90% of water, right? So when you put a material that can swell the 90% of it, and then they are also biocompatible. So the body, we can kind of mask the bioenvironment with the biopolymers. So what happens is the body won't feel that it's a foreign object, and the immune system is not triggered, and it's not going to attack the meniscus that you have planted. And plus, in our meniscus, we were trying to put like peptides and the components that can mimic a cell. And then once, when you do it in a petri dish, that's what we do in research, right? So when you plant like normal cells in the petri dish together with the hydrogels, they kind of feel that it's a normal environment, and they kind of grow naturally on that petri dish. I'm talking about not the body, just the cell culture that we do on the lab. So that's why it was kind of mimicking. And the fourth dimension, that the leaf that we told is a protein that our biology team extracted out of leaves. So basically that protein, what does is it converts, like it takes the oxygen and it splits water. So it did the same thing when it was printed and put in the water. That's what you were saying, that the bubbles were coming out of the beaker, the first video that you saw. Okay.
Ma'am, what challenges did you face during the development or implementation of this technology?
Oh, you know what? It's not easy to put a biomolecule into a polymer. That is the first thing. Their environment is different. You have to mimic, you have to coat it with peptides or amino acid sequences, something like that, to make them feel that, okay, I am in my environment. That is the first thing, how to stabilize a biomolecule into a polymeric environment. And the second one is how to print it, because you can print polymers. And you know that the printing is basically on, I don't know whether you have seen the thermal printers or the UV curing printers. Ours was UV curing. So that means when you print it, you are printing a liquid, and then the liquid should polymerize and form into that structure that you are printing. So there are a lot of, and then you have to hit it with the exact polymerization beam or the UV that is required. These are all the things that there are a lot of tiny itsy bitsy things that you are supposed to be facing throughout. It's not an easy project. And I told you it's still in the medical team is working on it, and I don't know the updates of that, but I am hoping that we will see it in the market soon.
How has this technology impacted society?
Oh, that is a good, you know what, when this video was, it aired in Global News in Canada, in Edmonton. It's a local channel. And I got phone calls from people to my lab, volunteering for meniscus transplant. Then only I realized how important the project is. But it's very scary because I didn't do anything. I don't know. I'm just a polymer person who printed a stuff which is fancy, and fortunately it worked. But the expectations of the patients who are waiting for a knee transplant is big. So it's definitely going to make an impact, and in the future, like the kidney donations or the organ donations, that can make it can revolutionize the field of that. And you know that now you have bionic hands where you can connect. If you have a prostate hand, you can connect to the brain, and then it can move according to your stimulations from the brain, right? So that far the research and development is going. And this one is like the 4D printed organs or something, is something that's very fascinating and useful for our society, but it will take a long time for sure.
Ma'am, what future improvements or possibilities do you see for this technology?
You know what? It's just an initial thing. It's just like telling like it was, think about Albert Einstein, Isaac Newton discovered gravity, right? Not Einstein, yeah. So Newton saying that there is gravity in the top, that's why things are coming down. It's that primitive. And it was in 2017, so it needs a lot of improvement on that. So it's that primitive. So it's just a concept that we can extract biomolecules, we can print it, we can incorporate them in polymers, and then them functioning as an organ. There's a huge difference. So it will take time. No more questions?
Thank you, ma'am, for sharing those points with us. It is great to learn how this project has created real change in the community. Thank you, ma'am.
Thank you, Tom. So the thing is that there was a question that you sent me. What problem in Kerala does innovations mainly solve, or like how the Kerala? Because I was doing in Canada, right? So there was a question how Kerala or like our native land can contribute to it. The main thing I would say is the resources, the human resources, the young and talented brains like you. That's what the infrastructure and everything is wow in Canada for sure. But the brain and the talent that you guys have, that's the thing that can definitely contribute to any R&D in any part of the world. So keep on doing your good work. My work is so happy.
Today's podcast helped us understand the purpose, challenges, and benefits of this innovation. It shows how technology can solve important problems in Kerala.
Uh-huh. Oh, I cannot hear you. Could you repeat it, Shreya, Rajaji?
Yes, ma'am. Is it audible now?
Yeah, it's.
Hello.
Yeah.
So today's podcast really helped us understand the purpose, challenges, and benefits of this innovation. And it also shows how technology can solve important problems in Kerala.
Okay, sounds good. I hope that you guys get a good grade for your project, and it can be an inspiration for you to go into the R&D field and revolutionize the society. You all can become Elon Musk or Steve Jobs or somebody in the future. And I'll be proud that I talked to you guys.
Thank you so much, ma'am. This talk was so incredible to talk with you. It was so incredible, so motivating what we've heard.
I'm going back and studying right now, right?
Yes, definitely. Okay.
Okay, then.
We really appreciate the time you've given us to talk about these things. We really appreciate it. Thank you so much, ma'am.
It was really good time, ma'am. Thank you, ma'am.
Yeah, take care. All the best.
Thank you so much, ma'am.
Yes, bye, ma'am. Bye. Thank you, ma'am.
Bye.
Bye, ma'am. Bye, ma'am.